Hello and welcome back. We're going to continue today talking about section 6.1, the law of sines. So yesterday we looked at using the law of sines, what it was. We didn't do this one, but we looked at finding the area using the sine, and we solved applied problems. Today we're just going to focus on what is called the ambiguous case of the law of sines. So just a reminder that this is the law of sines, and yesterday we were only using it for these types of triangles, where we knew two angles and one side length. And today we're going to look at what happens when we try to use it for these types of angles, in which we use two sides and one angle, but that this angle is not in between the two sides. So it would be a triangle like this, where we know side, side, and then an angle, and not that angle. So, back in geometry, you might have learned that, this is not a way to prove congruent triangles. And no, I'm not going to say that out loud. I'm going to call them side-side angle. And the reason that this is not a way to prove congruent triangles is because if I take this side length right here and swing it to the left, you can see I make actually another triangle that has this side length, and this angle. So there are actually two different triangles that have that same side, and angle. And we don't really know which triangle we're talking about if those are the only three measurements that we have. In fact, if you know side, angle, there are actually even more things that can happen than just this situation. For example, if you're looking at a right triangle, you could have this situation in which you have an angle, a side, and then this side isn't even long enough to reach, and you can't even make a triangle with those three measurements. Or maybe you've got a side length that's just exactly long enough to hit exactly one place, in which case there's exactly one triangle that can be made. This is the case that I showed you on the previous slide, in which there are two different triangles that could be made. This one, if you take these three lengths and try to swing this side around, you can't make another triangle, and then there's only one triangle that can be made. Here's one in which this side isn't long enough to reach, so you can't make a triangle with those three measurements. And then here's one where there's only, if A is an obtuse angle, there's only one triangle that can be made. So basically, there's kind of 6 different cases that can happen. Sometimes there's no triangles that can be made, like this one and this one. Sometimes there's exactly one triangle that can be made, like these three, and then sometimes there are 2 triangles that can be made, this one right here. Now, rather than try to learn rules to figure out which of these 6 situations you're in, what I like to do is just set up the equation assuming it's this one, and let the math and the calculator tell you whether or not there are 2 answers. If you're doing the online homework and you check the question help, it'll probably give you some rules that I'm not going to get into about trying to determine which of these cases we're in, and I'm not going to use those same rules. If you watch this video, you will see what I recommend you do. So let's take this one. Determine the number of possible solutions for this triangle. Angle A is 63 degrees, side length A is 18, and side length B is 25. So basically what I do is I draw the triangle, and I just label A, B, C. So angle A is 63 degrees. Side length A, that's the side length opposite, angle A is 18 units, and side length B is 25 units, and you'll notice here's side, angle. And then what I do is I just set up the law of sines. Now, I don't know if there's 0, 1, or 2 triangles that can have these 3 measurements. I'm just going to set up the law of sines and see what happens. So 18 over the sine of 63 is equal to 25 over the sine of angle B. And then to solve this, I am going to cross multiply there. So I am going to do 18 times sine B equals 25 times sine 63 degrees. And then, to solve this for angle B, my next step would be to get rid of that 18 by dividing both sides by 18. And then I've got sine of angle B is equal to 25 sine 63 over 18. And then the final step in solving for B is to do the inverse sine. And I can type all that into my calculator like so. Again, making sure my calculator is set to degrees. I can type inverse sine of 25 times sine 63 divided by 18. And then again, I'm going to make sure I'm in degrees. I am. So here we go. And I get, oh no, error. What happened? Well, let's think about that for a second. I'm doing the inverse sine of 25 times the sine of 63 divided by 18, which you'll notice is about 1.24. So I'm trying to do the inverse sine of a number that is approximately 1.24, and you'll notice that number is more than 1, which means it's not possible. Which means there are no solutions to this triangle. That means that this triangle is not possible. That means my diagram is a lie. And what that actually means is this side length of 18 right here isn't long enough to reach point B there. That means that 18 units would only get me, I don't know, like there, and I could never get to this line no matter where I place this side length. So let's now look at another example where we're asked to determine the number of possible solutions for the triangle. Let's take a look at this triangle here. So I'm going to draw this triangle. And I'm going to label, actually, if angle A is 105 degrees, I'm actually going to draw an obtuse triangle, because 105 degrees is an obtuse angle. And there's A, and there's B, and there's C. And angle A is 105 degrees. Side length A is 73, and side length B is 55. So there's my side-side angle. So what I'm going to do here is I'm going to set up the law of sines. So that's 73 over sine of 105 degrees is equal to, side length B is 55 over the sine of angle B. And then to solve this, I'm going to cross multiply, and I get 73 times the sine of angle B equals 55 times the sine of 105 degrees. And then to get solved for B, the next thing I need to do is get rid of that 73. And then the next thing I'm going to do is do the inverse sine of both sides. And I get inverse sine of 55 times sine 105 over 73. And then my calculator can give me that answer if I type it in all at once. So inverse sine of 55 times the sine of 105 degrees divided by 73. Oops, I did 555. Let's get rid of one of those. Okay. So you can see that my calculator tells me my answer here is about, let's go to the nearest 10th, 56.46.7 degrees. But here's the issue, and that is your calculator is dumb. And what I mean by that is, if you think back to when we learned about inverse sine, there's more than one answer. If you think about the sine function, sine is positive in quadrants 1 and 2 and negative in quadrants 3 and 4. So if you're looking for an angle that has a sine of whatever this is, there's actually going to be two different answers on the unit circle. There's going to be one answer in quadrant 1, and there's going to be another answer in quadrant 2. Now this answer right here, my calculator found is 46.7 degrees. But there is another answer to this, and your calculator doesn't find it. You have to know you're looking for two answers, and this other answer will have this same reference angle. So we have to do 180 minus that reference angle, which is 46.7. So to find my quadrant 2 answer, I do 180 minus 46.7, and the other possible answer is 133.3 degrees. So that's an or 133.3 degrees. So your calculator is only going to give you one of these two answers when you solve for a missing angle using the law of sines. You have to know that you have to go find the other answer. However, you might be noticing that this angle can't be that big because there's already a really big angle in this triangle. And a triangle can only have 180 degrees total when you add up all the angles, which actually means after we find that second possible answer, we then cross it out because we determine it's not possible because it would make the sum of our angles more than 180. This means that this triangle has only one possibility for angle B, which means that this triangle only has one solution. I could go find the other missing parts of this triangle if I needed to, but this question, you'll notice, just asked me to determine how many solutions were possible. So that's all I did, and if I needed to do more, I could, but I'm going to stop right there with this example.